Today we're talking about estimating angle measures, which is kind of a cool skill to just have because protractors, no one carries them around in their pockets. Sometimes it's useful to be able to estimate an angle measure. What about an angle like this one? That's pretty easy to estimate, right? You can recognize that as a right angle, and so you know that it's probably 90 degrees. Maybe it's slightly off, but if it is a true right angle, it's 90 degrees. This one's also probably pretty easy for you to recognize because it just looks like it's half of the angle that we saw above. So this looks like half of a right angle, and so it's 45 degrees. So 90 and 45, or maybe even 135, which would be like this, are pretty easy to recognize because we have the good reference point, which is a right angle. Those are easy to recognize. But what about for other kinds of angles? That's kind of hard to figure out. For example, could you estimate the number of degrees in this angle? Well, you might be thinking that it looks kind of like a 45-degree angle, but if you imagine a right angle here, then it seems like this ray is a little bit closer to this side than it is to this side. This is a little bit more than a 45-degree angle, but we can't really give much better of an answer than that. So today we're going to learn a new trick for being able to approximate angle measures to within about 5 degrees, which is a pretty cool trick. So we're going to learn a trick to give us some new reference points, and that is to think about a clock. So most of you can imagine a clock pretty easily, or at least could draw one if I asked you to. And you know that this is a circle, so it goes all the way around. And so how many degrees are in this full clock? There's 360 degrees in this full circle, right? Of those 360 degrees, there's some subdivisions. This is how thinking about a clock is going to help us break down degrees into smaller chunks. Because you know that of this 360 degrees, there are 12 big divisions for each of the hours, or if you're thinking about minute hands, for every 5 minutes. If we divide that 360 degrees then into these 12 hour-long chunks, then we can see that there must be 360 divided by 12, or 30 degrees in between each hour measure. So if I had an angle that went like this, that would be a 30-degree angle, right? What if we want to get even finer? What if we're going to get more precise? Well, we also have these, each of those big blocks are divided up into these minute blocks. So we just said that this from here to here is representing 30 degrees. There are 5 minutes in there. So how many degrees do you think correspond to each minute? You're hopefully thinking about dividing that 30 up into those 5 groups and getting 6 degrees. So this angle, if there was an angle where the hour hand, let's say, was pointing up at the 12, the minute hand was pointing to 1, that would be the time 12:01, then that angle by those minute hands would be only 6 degrees. So how can we use this? If we think about our angle from before, and you kind of just imagine a clock, maybe you're just imagining a clock put over that, where one of the rays is pointing up at 12 and the other is pointing somewhere else, it's pretty easy to kind of estimate or count how many minutes there are. So if these were, let's say, both minute hands, so maybe the minutes change from here to here, how long would that have taken? You can count it up. It's a block of 5 minutes and then 3 more. 8 minutes passed from when the minute hand was here to here. We know that each minute represents 6 degrees. So this angle then is about 48 degrees. 8 minutes times 6 degrees per minute. See if you can estimate, see if you can estimate angle BOC using this method. We have 2 choices. One is we could turn our head so that CO is pointing straight up, and we can imagine, if the 3 o'clock would be a right angle, probably be over here. So this seems like a little bit less than 15 minutes. Could you kind of imagine where the 1 o'clock and 2 o'clock angles would be? We can put up our clock like this, and does that make it easier to see? In reality, probably none of us are going to just in our head imagine a clock that has minutes marks. So that's why I'm using a clock now that just has the hours drawn, but we can still use it. Clearly it's between 10 minutes and 15 minutes, but what would you say? Is it a little bit closer to 10 minutes or a little closer to 15? To me, it looks like it's a little bit closer to 2. So I would estimate that this would be about 12 minutes. Now, I might be off by a minute or half a minute or something like that. That's okay. We're just estimating, so we're just trying to get close. So for this angle, I would estimate that it's about 12 minutes times 6 degrees per minute, or 72 degrees. If we take a protractor and make sure that we're using our protractor correctly, just to review that, we put this axis, there's kind of a cross usually, or a place that might be punched out. That goes right on the vertex. One of the rays you line up with the side that goes between that point and one of the sides that says 0 and 180. It doesn't matter. You could orient it with this way lined up or this way lined up. I'm just doing it like this. Then you see, where does the other ray intersect? And it intersects here. We have a choice, right? It looks like it's between 70 and 80, or you could think that it looks like it's between 100 and 110. So again, the question we ask ourselves with a protractor is this angle acute or a right? Is it acute or obtuse? If it's acute, we're going to use the smaller of the numbers. If it's obtuse, we're going to use the larger of the numbers. This angle, we already said, is less than 90 degrees, so we're going to go with 75. So our guess was that it was 72, and when we measured it, it's about 75, so pretty close. Now it's your turn. Can you do angle DOC? That's this angle here. Pause for a second and try to figure out. You might imagine turning your head all the way to the side so that the ray OD looks like it's pointing straight up. So, did you try it out? If you put on a clock, maybe imagine something like this. Ray OC looks like it's pointing again somewhere between 10 and 15 minutes, but this time it's a little bit closer to the 3 than it is to the 2. So you might be thinking this would represent about 13 minutes or 14 minutes. It's probably a little bit hard to tell, but either of those would be a good guess. Those would correspond to something between 78 or 84 degrees. That would be 13 times 6 and 14 times 6. Let's get a protractor and actually measure it. So if we line it up, this time I'm using the other side of the protractor just because that's what's easiest to line up here. Then it looks like ray OC goes right about here. So I could interpret that as either being around 80 degrees or 100, and I know that this is an acute angle, and so it looks like it's about 80. Looks like it's actually a little bit more than 80, so maybe 81 or 82 degrees. Probably 81 is a better guess, and that's exactly in the range that we thought. We thought that it was between 78 and 84. We're good to go.